In the upcoming comparisons between a rotating spherical Earth and a non-spinning flat Earth, we will avoid exploring the seemingly endless back-and-forth arguments commonly found between the standard heliocentric model and the geocentric perspective. Instead, our focus will be on highlighting the consistent pattern that emerges when evaluating these two models through a select number of real-world examples drawing from both heliocentric and geocentric perspectives. The heliocentric model, with its spinning, spherical Earth concept, consistently requires an array of intricate scientific calibrations, adjustments, and fixes for its highly implausible assertions to hold up. The geocentric model, with a flat, stationary Earth at the center of our world, requires no use of adjustments, supplementary phenomena, or highly complex explanations to demonstrate its straightforward and uncomplicated operation. It just works. In the upcoming examples and scenarios, we will demonstrate the use of Occam's razor, named after the English Franciscan friar, philosopher, and theologian William of Occam. This philosophical and scientific principle advises selecting the simplest hypothesis with the fewest assumptions when faced with competing explanations that predict similar outcomes. While I am certainly not telling you what to choose, I do aim to highlight a well-understood cognitive methodology that is straightforward and entirely applicable to our illustrative content moving forward. A simple and relatable application of Occam's razor involves waking up one morning, looking outside, and noticing that the streets are wet. Let us now explore 4 possible explanations for waking up to wet streets, noticing that each subsequent explanation requires more assumptions than the previous one, illustrating the principle of Occam's razor, considering the simplest explanation that requires the fewest assumptions. 1. It rained overnight. This is the simplest explanation with the fewest assumptions. Rain is a common and natural occurrence that can easily explain wet streets. 2. A street cleaner passed through and washed the streets. This requires more assumptions than simple rainfall, such as the operation of a street cleaning service at that time. 3. A large number of vehicles with wet tires from a nearby car wash drove by. This explanation needs even more assumptions, not only the existence of a nearby car wash, but also the coincidence of many vehicles passing by shortly after getting washed. 4. Water mains broke and leaked onto the streets. This is the most complex explanation, requiring multiple assumptions about the infrastructure failure and its specific location relative to the observed wetness. Now, let's examine a real-world scenario where we can quite easily apply Occam's razor and assess the narrative presented by NASA and academic scholarly bodies. We will explore the 4 astounding velocities attributed to Earth by NASA and modern academia, alleged to occur simultaneously, in numerous directions, and even along arcing trajectories. Take a moment to decide if these 4 simultaneous and rapid movements seem plausible, considering that we do not perceive any sensation of them happening to us right now. First, Earth is claimed to rotate on its axis at about 1,000 miles per hour. Next, Earth is claimed to orbit the Sun in an elliptical path at about 66,600 miles per hour. Lastly, our entire solar system, which is also in motion, is said to orbit the center of our galaxy at a speed of approximately 514,000 miles per hour, while our galaxy itself is said to be spiraling through the universe at an astounding speed of about 1,300,000 miles per hour. Is it truly possible to rationalize and account for these extraordinary speeds and directional disparities, thus justifying our complete lack of perceived motion? NASA and the scientific community attempt to account for our lack of perceived motion through 5 key concepts. 1. Inertia and uniform motion. Inertia is a property of matter where an object will remain at rest or in uniform motion unless acted upon by an external force. When Earth and all objects on it travel at a constant velocity, there is no acceleration or deceleration to be felt. 2. lack of reference points. On Earth, we lack fixed points in space against which we might directly measure our speed. In space, distant stars and galaxies can serve as reference points, but they are so far away that their relative motion appears very gradual, except over long timescales. 3. Relative motion. All motion is relative. We measure the speed of one object relative to another. On Earth, everything, including the atmosphere, is moving together at the same speed and direction due to Earth's rotation and orbit. There is no external point of reference that we perceive in our everyday life that would alert us to our speed. 4. Gravitational forces. Our entire solar system's movement through the galaxy and the galaxy's movement through space are influenced by gravitational forces, which are smoothly applied and do not result in perceptible changes in speed or direction for those living on Earth. 5. Scale and human perception. The speeds mentioned, like Earth's rotation at 1,000 miles per hour, or the galaxy moving at over 1,000,000 miles per hour, are incredibly vast on a human scale, but space is unimaginably vast. The distances involved dilute our ability to perceive these speeds. For example, despite Earth spinning at 1,000 miles per hour, the large circumference means it takes 24 hours to complete one rotation, a rate too slow to feel. Although quite sophisticated, these explanations can be overwhelming and difficult to integrate into a coherent understanding. As a result, the official narrative often becomes convoluted, causing many people to stop questioning it due to a sheer lack of comprehension. This presents an excellent opportunity to apply Occam's razor, especially for those now considering the possibility that Earth is not in motion as the simplest explanation. The geocentric model, which posits a non-rotating, fixed and immovable Earth, explains our perceived lack of motion straightforwardly, requiring no explanations. In contrast, the heliocentric model continually requires adjustments and far-reaching explanations to maintain its credibility. Given the everyday lack of perceptible motion on Earth, should we perhaps start to consider the possibility that the simplest explanation is indeed that the Earth is motionless? Or should we continue to accept the complex multitude of explanations that attempt to support the heliocentric model? I certainly understand the reluctance of most people to challenge the mainstream view, given the social pressures of being labeled as conspiracy theorists. It is extremely difficult to introduce these ideas to others, which assert that we have been misled to a level this extreme about the true nature of Earth and cosmology. But I implore you to do just that.